So we have got our formal grammar and now we know the rules of our programming language. But how does a compiler or a interpreter in this case knows how to parse this program, how it understands or how it reads the program? It's still a black box for us. Now let's explore how a compiler can understand our language. We have a concept called lexing. As we saw in our first video, we know that lexing is just a simple conversion of a given source code into a list of tokens. We know that lexing or tokenizing is nothing but converting our syntax into a list of tokens. Now the problem is there's always some errors in our code. For example, there can be any random space here, or there can be no space after the 300, or let's say there is a lot of space after the variable x. It can be any syntax, but each of this input should provide the same output. Here, irrespective of what line you give to the Lexer, it should give you the same output. Now, this is a little bit tricky because now you have to ignore all the spaces. There are more conditions here. Let's say someone likes to write if with a curly brace on the same line, and someone likes to write it on the next line. We will dig deeper into how to write this type of language acceptors. So in this video, we will be building a C++ tokenizer from scratch. Given any syntax, your code should convert the given syntax into a list of tokens as we talked about. In this example, it is clearly written a var is there of type keyword. Then there is an x identifier equal to assignment operator. Then there is a 300 integer, etc. etc. So we need to define types of this tokens. So let's find out what types our tokens can be. So let's take the same example, var x equals to 300 plus 20. Let's assume that we don't have any other part of programming in our language. This is only the language which is it accepts. So we will not go into and add all sorts of functions for if, else, switch cases, etc. So let's say what tokens it would need. It would need a declaration token, a plus sign token, equal to operator, and some identifiers and numeric values. Yeah, we have identifier token, then there are integers, floats, there is assignment operator, then plus and a declaration sign. So now we want to know what part of the string corresponds to what part of the token. So we need to identify the string first and then find what token it belongs to. So here is the example. We found var and then we need to assign the keyword token to the var. Then we found x, then we need to assign identifier token to it. Found equal to sign, we need to assign assignment token, etc. etc. So before we write our program, let's do a dry run on this statement to figure out what things we need and what things we have to functionize and atomize out. Let's do a dry run on this kind of syntax. We know that we have all this type of tokens available and valid keywords are just var for now. So we will use a single pointer approach. We will traverse from left to right, and once we encounter one or other thing, we will classify it into this type of tokens. Let's start with this string. First we encounter is a V. Now an identifier and a keyword both can have V. We need to identify which is identifier and which is keywords. We have a list of keywords, so we can try to understand that if it is a var, we will check in the valid keywords if AR exists. If it exists, we will mark it as a keyword. If it doesn't exist, we will mark it as identifier. So we encounter a V, then we encounter an A, and we encounter an R. We know VAR belongs to this valid keywords. This therefore is an keyword. We'll mark it as keyword. We'll move our pointer to the next place. Then we encounter a white space. Now we don't have any keyword for a white space. So what we will do is we will ignore this white space. And we advance to the next character. Next we found an X. Now a keyword can also start with X and something, and an identifier can also start with X. So again we have a dilemma. So we need to take care of this. So we found X. We will check if there's any other character. There is a space. We ignore the space, and now we find if X is invalid keywords. If it is, we will mark it as keyword. But it is not right now, so we will mark it as identifier. Again, advance to the equal to sign. We can assign a assignment token to it. So assign it a assignment token. advanced. Similarly, we find a 3. Now a 3 can be a number 2, but we have to check what comes after 3 and make it also a part of this cluster. We cannot not do 3 as a float or an integer, but 300 entirely as an integer. So we have to take care of this. Then we encounter a plus sign, and then we encounter a 20. This is how the flow should be. Need an advanced function. What this advanced function will do is it will move the character, move the pointer to the next character. It should store what was the previous character, and we also want to identify if it is a keyword and if it is an identifier. We need a function to handle letters. Let's say if we encounter a letter, we'll pass the entire letter or entire string to this function. It will look at the entire string and find and decide if it's a letter or a string. Then we need to identify if it is a number. If it is a number, how long it is. Let's say 3, 300, 3,000, 30,000. And if there are commas, how should we handle it? There is a full stop. How should we handle it? If there is a F after the numbers, how should we handle it? So we have a class Lexer, and we have few parameters to store. We want to generate tokens. That's why, so we want to generate tokens. That's why we should have a storage for generated tokens, and after we are done tokenizing, we will return this. Yes, we need to store our input string so that when process we don't change the original string. Then we should know what the current index is for our pointer. So let's say we know that this section is already processed and we don't need to process it again. Then we need to store our current character, what the current character is. Based on this character, we will use our functions. We will try to identify if it is a keyword or if it is an identifier. This will be done via this current character. Now position and scope. It is a later part. Position is just for error handling. So this is how all things we store. These are all the features we will add. Let's say handle new line. What will happen when we encounter a new line? What will happen when we encounter a white space? It is ignored for now. What will happen if we encounter a special symbol, a binary operator? What happens if we encounter a dot? Now this advanced function is nothing but just to increment the index, and we have made a parameter to store what the current character is. So we need to update it here also. And if the current character is not found, what we will do is just extend the current string and add backslash zeros to it, or throw an error message that string has ended, or maybe just shut down the lexing part and return what our tokens are. Now in this tokenize function, we receive our source code and we need to return the list of strings. This is entirely our tokenize function. What it does is it just looks through the entire source code line one by one character time, and there is a huge switch statement to handle each and every character. So let's say there is a comma, so we have handle comma. There's a semicolon, then we have a semicolon operator, then we have, let's say, a double quote, a string return handler. So why are we making handlers for all this, not just using well, logic? Let's say if we encounter a white space, then just add a token type of white space, call it a day. The thing is, let's say if we have equal to and following the equal to, we have another equal to, then the meaning changes. It is not an assignment operator now. Let's take a look at what these handlers are. So when we encounter a new line, we just advance to the next character. We ignore the new line. Here's the handle numbers function. Now this is a little bit complicated function because a number can be a float, a number feature, can have a full stop or a decimal point, it can have F's, E's. So we need to make sure that we take care of all this HK. When the handle number function is called, we know that the while loop we saw earlier counted a number or a digit. That's why the handle number is called. So till now we only have one digit, and we can say that the current token type must be an integer. We take a look at the next character. So while the current character we advanced, right? So if the current character points to the next character now. While the current character is still a digit or a number and a full stop maybe, then we follow this. We encounter a point. Then we change the token type to a double and we add that point to our a string of numbers. Similarly, if there is a hyphen, we know that this is a negative number, so we take care of that gracefully. This way we process the entire number and then we advance and return. So let's take a run through on this. So let's say we encountered a 1 and call our handle number. Our pointer is still at 1, and what we do is we check if it is a number. Yes, first we add it to our number string, then we advance. It's still a number, we add it. It is not a digit but a full stop. We also add it because it is a valid number. Then we advance to 3, add the 3, advance to 0, add the 0, we advance to f. Now, f is not a digit but a literal saying is a text saying that this is a float. So we have seen that we already marked this code as double. Now after we encounter this, we can be sure that this is not a double after encountering the f's, and we can mark it as float. Now let's do a rundown for this line. So we start at the character v. We know that this is a character and it can be either a word or an identifier. We call the handler for that. It checks, it stores this to a variable. Then we advances character. We find a, then we advance, find the r. Then we again advance. We find a non character. So we know that this is the only part which we should worry about. And after that, the function itself checks r is in the list of the valid literals, or let's say valid keywords. If it is not, it will be an identifier. If it is, it's a keyword. We found a keyword. The function returns this keyword. Then we advance again. Found a x. Again, the same function is called with the literal x. It stores the x, it advances. We find a space. Space is not a valid character. End it here. Find if x is a valid key. It's not. So we mark it as identifier and return the token. We advance again. Find the equal to sign. Call the equal to handler. It stores the equal to sign and advances to the next character. If it is a plus, or let's say another equal to sign,